Hello everybody, and welcome to a new section on trigonometry. So I believe this is section 7.5, I think. There you go. So what we're going to do is we're getting into the part where trigonometry earns its reputation of being one of the more hated parts of mathematics, because we're getting into the formula part, where there's little geometry and it seems to be a lot of algebraic manipulation. And what we're going into is the sum and difference formulas, and that shows you how to take the sine and cosine and tangent of the sum of two angles and the difference of two angles. Okay, and you say, okay, well, so what? Well, we're going to see that this has a lot of nice applications in the next section. But this is pretty important. And these formulas are kind of amazing. That the problem is, it's first you need to remember them, and then kind of understand where do they come from, or why are they coming out of thin air, it seems. So we have the sine of, if alpha and beta are two numbers, the sine of alpha and beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And if we have the cosine of alpha plus beta, that's cosine alpha cosine beta minus sine alpha sine beta. And I won't read all the others because you can see them, they're right there. And the way I kind of remember this is that the S in sine signs for symmetry. So whether it's a sine of a sum or a difference, it's very symmetric. They have the sines and cosines are together. Okay, and you have a plus where you think there would be a plus, and a minus where you think there would be a minus. With cosine, it's the opposite. Okay, the cosines are grouped together and the sines are grouped together, and the sign is the plus and minus are the opposite of what you would think. So for a plus here, you have a minus here, and a minus here, you have a plus here. Okay, and then the tangent. Then you can also have the formulas for the tangent of alpha plus beta. For the tangent of alpha plus beta, for example, is tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. I'll be honest with you, I think I've been teaching for 34 years, and I maybe have used these last two formulas maybe once or twice when I was teaching. Okay, so it's kind of a little silly, because if you know what the sine and cosine are, you can find out what the tangent is. All right, so your book has a kind of a nice proof of this using a unit circle. Okay, and I encourage you to look at that in your book. There's a lot of some algebraic manipulation, okay, but it basically uses the distance formula. Now what I'm going to do is I'm going to give you an alternate proof, which is a lot more visual and a lot more geometric. The downside is it only works for a few values of alpha and beta, but we're going to say it can be extended to other cases. So why is this? Why are these true? So we're going to prove this. So what we're using is this notion, the version of the Pythagorean theorem. That is, if we have a right triangle and the hypotenuse has length h, and this angle is theta, then the opposite side has length h times sine theta, and the adjacent side has length h cosine theta. Okay, I think we all know that by now. So the way we do this, prove this, is I first drew a right triangle where the angle is alpha, a right triangle where the angle is beta, and I stacked it on top of each other. And then I sort of drew a square around this. And I wanted to make the hypotenuse of the second triangle equal to 1. Okay, so we have this nice little square which consists of these 4 triangles here. All right, now because this hypotenuse has length 1 and this angle is beta, then the length of this side has to be cosine beta, and this is the sine of beta. That's what this side is. Okay. All right. Now we also now know that, because now we know that we know what this hypotenuse is. That means that because this angle is alpha, this is going to be cosine beta cosine alpha, and then this will be cosine beta sine alpha. All right. Now, a couple other things is that this angle has to be alpha. And the reason for that is we know that this angle and this angle, alpha plus 90 degrees, plus whatever this angle is, has to equal 180. Well, here we have well, whatever that this angle, if we could call this, I won't write this, so let's say we just call this angle y. We have alpha plus y plus 90 degrees is 180. Here we have 90 and a y, and the sum of these three angles has to be equal to 180, so this angle has to be alpha. Okay? And now because of that, we have another right triangle here, and this hypotenuse is sine beta, so this side is going to be sine beta cosine alpha, and this distance right here is going to be sine beta sine alpha. Okay. All right, now one last thing here is that these angles together is alpha plus beta. Okay, I think that's pretty clear. And from basic geometry, we can see that this angle is equal to this angle. So this angle is alpha plus beta. Okay, from basic Euclidean geometry. And then this we have a right triangle here, and so the hypotenuse is 1, so this side is going to be the sine of alpha plus beta, and this distance is going to be the cosine of alpha plus beta. All right, because that's what this distance is. All right, now we're all set. Now we can basically read off the formulas that we want, because we can see that the sine of alpha plus beta is equal to this distance plus this distance. Okay, and if you just rearrange the factors, that's how we get this formula right here. And we also see that this distance plus this distance equals this distance. Okay, so we can see that the cosine of alpha plus beta is this distance minus this distance. Okay, which proves the second part. Okay, so this is the proof for the first two formulas. Okay, now granted, it only works if alpha and beta are in the first quadrant and their sum is in the first quadrant, but we can also sort of just go ahead and you can apply this to other cases. Okay. Now for the fourth part, for 3 and 4, this is just going to be, we're just using the fact that because we can write, for example, the sine of alpha minus beta. We can write this as a sum. This is a sine of alpha plus negative beta, and we can just use our previous formula, the one we just proved. So this is going to be sine of alpha cosine of minus beta plus cosine of alpha times the sine of minus beta. And because the cosine is an even function, this is still cosine of beta. And this, because sine is an odd function, this is minus sine of beta. Okay, so sine alpha cosine beta minus cosine alpha sine beta, which is exactly what we have up here for number 3. And then you can do the same thing for the second part. You can set a cosine, or the fourth part, cosine of alpha minus beta. This is going to be the cosine of alpha plus minus beta. All right, so this will be the cosine of alpha cosine of beta, or minus beta, minus cosine of alpha, or sine of alpha sine of minus beta. Okay, and then this is going to again be minus sine of beta. This will be cosine of beta. So this minus sine cancels out with this minus sine, And so you get this part. All right. And then for the formulas for 5 and 6, I was going to do this, and I just decided I don't want to write it out. The proof is in the book. It's basically you're just taking these, taking this expression, dividing by this expression, and then multiplying and dividing by something else, and doing a little algebraic manipulation. Okay, so it's not that hard. But okay, so let me just do a few examples here. So cosine of 15 degrees, we can now figure out what that is because we can write 15 as 45 minus 30. Right? So using that, this is the cosine of 45 minus 30. So this will be the cosine of 45 degrees, cosine of 30 plus sine of 45 degrees, sine of 30. Okay, so and that is square root of, so this is the square root of 2 over 2 times cosine of 30 is 30 degrees is square root of 3 over 2 plus the sine of 45 is square root of 2 over 2, and the sine of 30 is 1/2. And this simplifies to square root of 6 plus square root of 2 over 4. Okay, like that. All right, the sine of 15 degrees, then we can find this. This is, again, that can be written as 45 minus 30. So this is the sine of 15, or sorry, the sine of 45 degrees times the cosine of 30 degrees plus the, or actually minus, it's a minus because it's a difference now. And then this is the cosine of 45 degrees times the sine of 30 degrees. So this is square root 2 over 2. This is square root 3 over 2 minus square root 2 over 2 times 1/2. So this is square root 6 minus square root 2 over 4. Okay, this time. So we have a minus sign this time. Okay. The cosine of 7 pi over 4, let's go to radians. I think we can really see that. 7 pi over 4 is the sum of 4 pi over 12. I'm sorry, 7 pi over 12 is 4 pi over 12 plus 3 pi over 12. So this is going to be the cosine of 4 pi over 12, by the way, reduces to pi over 3, and 3 pi over 12 is pi over 4. So these are the two angles we use. So this is cosine of pi over 3, sine, or cosine of pi over 4, minus sine of pi over 3, sine of pi over 4. Okay. And this is 1/2 times square root 2 over 2 minus square root 3 over 2 times 1/2, or square root 2 over 2. Okay. So this simplifies to square root of 2 minus square root of 6 over 4. Okay. And let's just do a few more. The tangent of 7 pi over 12. We can use get to use the tangent formula. I know you're all excited about that. Okay, about as excited as I am. Okay, so this is going to be the tangent of pi over 3 plus the tangent of pi over 4 over 1 minus the tangent of pi over 3 and the tangent of pi over 4. So, and then you just have to remember your tangents. Tangent of pi over 3, you have to remember that's equal to square root of 3. Tangent of pi over 4, that's the easy one, that's equal to 1. So, okay, so this is square root 3 plus 1 over 1 minus square root 3, whatever that is. let's look at the cosine of 5 pi over 12. Key here is to how do we write that as, and we can write this as a sum. We can write this as 3 pi over 12 plus 2 pi over 12. And then this reduces to pi over 4, and this reduces to pi over 6. Okay, and we know both the three values of those. So this will be the cosine of pi over 4 times the cosine of pi over 6 minus the sine of pi over 4 times the sine of pi over 6. Okay, which I'll just tell you is the square root of 6 minus the square root of 2 over 4. Okay, you plug everything in. All right, last one on this page is now this is a little, you have to do this is a little bit different. Here I'm actually giving you an expression in a more complicated form, and you look and say, okay, well, sine of 20 degrees and 80 degrees, these are not angles that we've memorized from our unit circle. Okay, so how do we do that? Well, the thing is, we're not being asked to find what the sine of 20 degrees is. We're asked to find out what this expression is equal to. And the tip off here is, I think you can see that if you take 80 minus 20, that's 60. And that is, 60 degrees is an angle that we know a lot about. Okay. Now, the thing here is we know that here the sines and cosines are grouped together, so it looks like we probably want to write this as a sine of a difference or a sine of a sum, okay, or something like that. If we take the sine of 60 degrees, it can be written as a sine of 80 degrees minus 20 degrees, and then this, using our formula, this is going to be the sine of 80 times the cosine of 20 minus the cosine of 80 times the sine of 20. Now, if you look here and look here, they're not exactly equal to this. In fact, this is the opposite of what we're asked to find. Okay. But that's okay, because so we can just pull out a minus sign and say this is minus, and then this will be the cosine of 80 sine of 20 minus sine of 80 and cosine of 20. Okay, pull out a minus sign, and this now is what this is. Okay, all right, so the sine of 60 degrees, we know that is the square root of 3 over 2. Okay, so the square root of 3 over 2 is the opposite of this, so this must be equal to minus the square root of 3 over 2. Okay. So sometimes you have to do a little playing around, even if you have the right, know your formulas. Okay, all right, so digest this, and then we will see you in part 2 of this video.